Welcome back to another video. This is Dr. Tarcia Hubert, and in this video, I am going to be talking about statements, negations, and quantified statements, okay? So this is the beginning of our discussions on logic. And so this is going to probably be completely different than what you're used to seeing in a math class. So we're going to be talking about logic, and we're just going to start today, jump right in with statements. And so since this one had a lot of writing, it's a lot of words, I decided not to show my face and be in front of my board, my whiteboard. I'm just going to go through this presentation and just basically give you a lot of definitions and a lot of examples, because this is the very foundation of logic, okay? So it's really important that you understand these definitions as we go through, because again, this is the foundation and we're going to be building on this, all right? So starting off, so the very first thing is statement. What is a statement? A statement is a sentence that is either true or false, but not both simultaneously, okay? So it's just basically something that has to be true or false. So here goes some examples. So like Austin is the capital of Texas. That's either true or false. And I'm not even really worried about whether it's true or false. I just need to know that it can be true or false. Jim Carrey directed Godzilla vs. Kong. So Godzilla vs. Kong just came out. And so Jim Carrey directed it. True or false? And you don't have to know whether it's true or false. It just needs to be able to be true or false. So what are some non-examples of statements? I'm glad you want to know. So here are some non-examples. So think before you speak. So that's not a statement. That cannot be true or false. That's actually a command, an order. You're telling somebody, think before you speak. Like, don't just say whatever comes to your mind. Like, think about it and then say it. Am I annoying to you? So that's actually a question. So I'm asking somebody, am I annoying you? So that's not a statement. Can't be true or false. Taylor Swift is the best singer of all times. Is that true or false? So now that's actually an opinion. So that's why that one isn't a statement. And since it's an opinion, that is not a statement. That sentence, basically, the value of it, whether it's true or false, will change from person to person. So I told y'all in a previous video that I think Beyonce is the best singer. Not of all times, though, but like right now, living today, of all the artists that are out there. And so I would definitely disagree with that, which somebody else may think that Taylor Swift sings better than Beyonce, who might think that that's true. Okay. So if it's an opinion, it's not a statement. It has to be able to be true or false. Let's keep going. So we use letters, lowercase letters, to represent statements. Typically P, Q, R, and S, those are the most common ones that we use, but you can use other letters than those. And so just to take the two examples that we had earlier, Austin is the capital of Texas. So if I wanted to let P represent that statement, I would write it like this, the P with the colon and then the statement. And the same thing, if I wanted to let Q represent Jim Carrey directed Godzilla vs. Kong, I would do the same thing, write Q with the colon and then the statement. Now, a negation is when you take the opposite of the statement. So if the statement is true, the negation of it will be false. If the statement is false, then the negation of it will be true. So you're taking the opposite value of the statement. So for example, here's an example with two different parts. We want to form the negation of each statement. So the first statement is Kentucky Fried Chicken has a seafood buffet. So that could be true or it could be false. Again, we're not worried about whether it's true or false. We just want to know that it can be true or false. So the negation of Kentucky Fried Chicken has a seafood buffet would be Kentucky Fried Chicken does not have a seafood buffet. So you're taking the value of that first statement and changing it by basically just saying does not. So the second statement, today is not Monday, that can be true or false. So it just depends on what day you watch this. It might be Monday. It might not be Monday. I just want to negate that and take the value of it and make it the opposite. So instead of saying today is not Monday, the negation of it would be today is Monday. Okay. So when you negate something, you just basically take the value of it and you make it the opposite. We use this squiggly line as the symbol for negation, this little squiggly line right here. So, and we read it as not. So this is the negation of P or also not P. So that's the symbol for negation. So here's an example. Let P and Q represent the following statement. So P represents Trey the Truth is the mayor of Houston, and Q represents Quavo and Saweetie are happily married. All right. If you've been keeping up with social media and news and all that's going on lately, you know that Quavo and Saweetie have been in the news. All right. So whether those are true or false or not, we just basically want to take each of these parts A and B and express them with symbols. So if A says Trey the Truth is not the mayor of Houston, how will we represent that with symbols based on the fact that P, the statement P is Trey the Truth is the mayor of Houston? So that's not exactly saying what P is saying. That's saying the opposite of what P is saying. So P is Trey the Truth is the mayor of Houston. But A, our statement on A here, says Trey the Truth is not the mayor of Houston. So with symbols, that would be represented by the negation of P. That's the opposite of what we let P represent. So for our statement in B, Quavo and Saweetie are not happily married. That is the exact opposite of what Q is representing. Q represents Quavo and Saweetie are happily married. So to represent part B, our statement B, in symbols, that would be not Q or the negation of Q, because it's the exact opposite of what Q represents. Okay, so this is just how you take symbols, you take the words and you represent them with symbols. So here's another example. Let P represent the following statement. So P is the United States has the world's highest divorce rate. All right, so again, we're not worried about if it's true or false. We know that that statement can be true or false. That's what makes it a statement. All right. And we're letting P represent that. Well, we want to take the symbolic statement, the negation of P, and we want to write it in words. We want to express the symbolic statement, the negation of P or not P, in words. So we basically want to say P and make it say the exact opposite of what it's saying. So the United States has the world's largest divorce rate. The opposite of that would be the United States does not have the world's highest divorce rate. So you're just basically making it say the exact opposite of what it's saying. All right, here's another definition. The words all, some, none, or no are called quantifiers. So when you have words like all, some, none, or no, they are called quantifiers. And so that's going to lead us up into a quantified statement. A quantified statement is a statement that contains a quantifier. So if it contains one of those words, all, some, none, or no, that's considered a quantified statement. So here are some examples. All athletes play basketball. Again, I'm not worried about whether they're true or false. I know it can be true or false. That's what makes it a statement. Right now, I'm not worried about whether it's true or false. We'll talk about the truth value of it later. Here's another example. Some people have big heads. No common colds are fatal. And some people do not work hard. And so all of these are statements that can be proven true or false. And again, when you come to something like some people have big heads, you will have to define what is a big head, like the circumference of what head makes it big. All right, there are two equivalent ways to express quantified statements. So the statements are in the left column and the equivalent way of expressing it is in the right column. So if you say all A are B, then the equivalent way of saying all A are B is there are no A that are not B. Okay, so you basically just negate both the A and the B. There are no A that are not B. So for the statement some A are B, the equivalent way of saying that is there is at least one A that is a B. For the statement no A are B, the equivalent way of saying that is all A are not B. And I know this might sound weird right now, but we'll look at some examples in just a moment. And then some A are not B, the equivalent way of expressing that is not all A are B. So here are some examples. So for my first statement, I have all math teachers are nerds. So the equivalent way, according to the table that you just saw, the equivalent way of expressing all math teachers are nerds, you will say, there are no math teachers that are not nerds. There are no math teachers that are not nerds. So you negate the A, which is the math teachers, and you negate the B, which is the nerds. Some people have big heads. The negation of that, or not the negation, the equivalent form of that statement is there's at least one person who has a big head. There's at least one person who has a big head. No common colds are fatal. An equivalent way to express that is all common colds are not fatal. So you change the quantifiers and you negate the second part. And then for the last one, some people do not work hard. An equivalent way of saying that is not all people work hard. And that one sounds pretty simple. Some people do not work hard. Well, not all people work hard. So those are some examples. So negations of quantified statements. So we have two quantified statements here and their equivalent negation. So if the statement is all A or B, then negation of that is some A or not B. And if the statement is some A or B, then the negation of that is no A or B. So for example, all people take exams honestly. That's this first one, all A or B. So the negation of that is some people do not take exams honestly. So all A or B, the negation of it is some A or not B. So some roads are open. That's this one, some A or B. So the negation of that is no roads are open. The negation would be no roads are open. And then for this last example, it says the Board of Supervisors told us all new tax dollars will be used to improve education. I later learned that the Board of Supervisors never tells the truth. What can I conclude? And then express this conclusion in two equivalent ways. So I'm just going to go back to the last table. So it says all new tax dollars will be used to improve education. So if I go back to this table, that's the all A or B. So the negation of that is if they never tell the truth, that means they lying, which means I need to negate that statement. The negation of that is some A or not B right here. So I can conclude that some tax dollars, that's the A, will not be used to improve education. So if they didn't tell the truth, that means there will be some tax dollars that will not be used to improve education. Now, an equivalent way of saying that, if I go back to my equivalent slide, some A or B, the equivalent, or some A or not B, is not all A or B. This very last one down here. So an equivalent way of saying that, because we had some A or not B, is not all A or B. So let me go back. And so an equivalent way of saying that is not all new tax dollars will be used to improve education. And so this is saying the same thing as this statement right here. Some tax dollars will be used to improve education. Okay. So this is, again, the basics of logic, the very foundation. We talked about what is a statement, what is the negation of a statement, and also what are quantified statements and how to negate quantified statements. So we will build on this in the next video. So thanks for tuning in, and I'll see you in the next video.